All right, welcome. Today, we're going to dive into something really at the heart of artificial intelligence, knowledge representation. You can think of it as the secret sauce, the thing that makes the difference between a simple calculator and a machine that can actually think. So, let me kick things off with a question for you. What's the real difference between just knowing a fact, say knowing that jumping from a great height is dangerous, and truly deeply understanding what that means? That gap, right there, the one between raw data and actual wisdom, that is exactly what we're trying to solve with AI. Okay, so to really get to the bottom of this, we've got to first break down what we even mean by intelligence when we're talking about a machine. It actually boils down to three key parts. Let's call it the AI intelligence trio. And here they are. First up, you've got knowledge. Think of this as just the raw facts and the skills. Then you have reasoning. That's the process of actually thinking about all that knowledge. And finally, you get intelligence. And that's the ability to pull it all together, the knowledge and the reasoning, to make a smart decision when it counts. So you see the flow, right? Facts, processing, and then the smart action.
This example really makes the whole thing click. The knowledge, that's the simple fact. Jumping off the 20th floor is, well, it's fatal. The reasoning part is you thinking through the consequences of that. And the decision not to jump, that is the intelligent action. It's a perfect, maybe a little dramatic example of that trio working together.
But here's the thing, for a machine, just having a pile of facts isn't nearly enough. A machine doesn't have our life experience or our intuition, right? So for an AI, pretty much everything hinges on how that knowledge is stored and structured. It is all about representing it in the right way. And that, right there, brings us to the core idea, knowledge representation. It's the whole process of storing information so that a machine can actually make sense of it at the right time and use it to make a good decision. So you see, it's way more than just a database of facts. It's more like a blueprint for how to think. And this is exactly why it's so incredibly important. You've probably heard the saying, garbage in, garbage out, right? Well, this is the ultimate example. If you represent the knowledge incorrectly, the machine is going to interpret it incorrectly. Simple as that. Its decisions will be flawed. The whole intelligence of the system really just rests on how well that blueprint is drawn. Let's look at a couple of ways this can go wrong, and we can use some simple English to see it. First, you have a syntax error. Think of this as just bad grammar, like saying, I is going to Delhi today. Now, you and I, we can figure out what that means, but a machine, it might just get stuck on the error. But then you have a semantic error, and this one is way trickier. This is all about the meaning. Take the sentence, I ate the match while watching the food. Grammatically, it's perfectly fine, but the meaning is just complete nonsense. For a machine to work right, it has to get a handle on both the grammar and the meaning. So, okay, if representing knowledge correctly is the big goal, then how do we actually do it? How do we build these blueprints for an artificial mind? Well, we're going to walk through 4 of the main ways computer scientists get this done. 4 ways they help machines to think. So here's what we'll be looking at. The 4 big techniques are logic, semantic nets, frames, and scripts. Each one gives us a totally different way to structure information, covering everything from simple rules all the way to really complex stories. All right, first up, we've got logic. Now, this is one of the most fundamental ways to do it. It basically uses true or false statements and these simple if-then rules. If this is true, then do that. It creates a really clear, no-nonsense path for the machine to follow. It's pretty much the bedrock of a ton of classic AI reasoning. Next up, we have something called semantic nets. I know, the name sounds a little technical, but the idea is actually super visual. Semantic just means meaning, and net is, well, like a spider's web or a graph. So you're basically creating this web of interconnected ideas. A perfect real-world example? Google's knowledge graph. You know that little box that pops up with all the related info when you search for something? That is a massive semantic net in action. Okay, our third method is called a frame. And the easiest way to think about this is like a template or maybe a fill-in-the-blanks form. It's a data structure that has slots, which are just categories, and fillers for the actual details. This gives you a really fixed, precise way to structure knowledge. A perfect analogy is a railway ticket, right? It has those predefined fields. Your name goes here, destination here, seat number there. And here's a great example of a frame in action for a cow. The slots are the categories, things like ISA, legs, produces. And the fillers, those are the specific details. Mammal, for, milk. See how that works? It's just a super clean, organized way to lay out all the properties of an object. And that brings us to our last method, scripts.
Now, you can think of a script as sort of a superpowered, advanced version of a frame. Because while a frame is great for capturing a static snapshot of something, a script is built to represent a whole sequence of events.
So what's the real difference then? Well, if a frame is that static railway ticket just describing the properties, a script is the whole dynamic story. It describes the entire process. You going to the station, buying the ticket, finding your seat, the actual journey, all of it. It captures the whole sequence of actions, the different roles people play, and even the scenes.
So after looking at all these methods, logic, nets, frames, and scripts, we keep coming back to the one single most important idea here. The main takeaway from all this is that in AI, representation is absolutely everything. At the end of the day, the choice of how we build that internal blueprint for thinking, that determines the very nature of an AI's intelligence. It's not about how much data you can stuff into it. It's about the quality of the framework it uses to understand that data. That structure, that's what makes the difference between a dumb database and a system that can actually reason, learn, and make smart choices. And this all leaves us with a really fascinating and frankly, a really challenging question for the future. I mean, it's one thing to make a frame that describes a cow. That's pretty straightforward. But as AI gets woven into every part of our lives, how on earth are we going to teach it to represent these incredibly abstract human concepts? Things like fairness or justice or creativity. That is the next great frontier we have to cross.